I'm firstly going to show you a couple of methods you're probably likely to see in a lot of tutorials online, and these methods are incorrect and insecure, and I'll show you why. And then we'll look into how to correctly hash passwords in PHP. So let's create a password string we can work with. So I'm just using my Scratchpad here. I'll pop a link in the description, but you can just try this out yourself in any PHP file. It doesn't really matter. So I'm creating a new variable called password, and I'm just going to set this to a string, and we're just going to do penguin. Obviously this password input will be coming in from the user from a form or something like that, but for the purpose of this we're just going to use it in a string. But a lot of the time you see people using hashing algorithms such as MD5, SH1 and other members of the SH family. So to produce the hash, it's simply calling something like MD5 and then passing in the user's password. So if we just echo this out onto the screen, and you see this generates a hash for us of the password penguin. Now the problem with this is, no matter how many times we run this, it will always produce the same hash. So let's just take a look at this. I'm just going to create a for loop and loop over this. So we just created a simple for loop. We're going to loop over it 5 times, and we're just going to echo out the MD5 of passwords. And I'm just putting a line break here so you can see each individual line. Now if we refresh in the browser, we have 5 password hashes for penguin here. But look, they're all exactly the same. So this is the problem with these types of hashing algorithms. Let's take a look at SH1 as well. So we're just putting SH1 here. Let's give this a refresh. You see this gives us a slightly longer hash, but again, they're all exactly the same for the same input. This is open for attacks called rainbow table attacks. It's just basically a massive spreadsheet of already generated hashes. So somebody generates a load of passwords and then hashes them. And then all the attacker needs to do is loop through them and say, does this hash match anything within the rainbow table? And if it does, then they'll have access to the plain text password, because these algorithms always produce the same hash no matter what system they run on. So the attacker knows that this hash string means penguin. So to get around this, people started using a method called salting. So what this does is it adds a random string to each of the passwords. Let's take a look at this. So for the purpose of this, I'm not going to get too advanced. I'm just going to use mtrand to get a random integer. So people do all sorts of crazy random string manipulations to get some sort of pseudo random output. So let's just do a salt equals mtrand. And then what people are doing is they were just appending the salt onto the end of the password. So it's password append salt. And now because this mtrand is going to produce a random number every time, the password being put into SH1 to be hashed would be the password and then a random number. The password would be different every time. So let's give this a refresh. And you see this produces a different hash every time. This is a bit more secure than just hashing a password on its own, but this gives us a problem. When we come to check the password hash, we need to pass in current password and the same salt that we used to hash the password. What this meant was, in the database table, you'd have to store the hash password and the salt. So if an attacker got into your database, they would know what the salt was for that password. All they need to do then is open up their rainbow table of already known passwords and just add the salt onto the end of every one of them, and then they know the password hash again. So in PHP, they produced their hashing function for us called password underscore hash. So at the moment, the default algorithm for this is bcrypt. But there are other password hashing algorithms you can pick from. The good thing about this though is that it uses the crypt C library underneath, which is extremely well tested within the Unix environment. And things that are well tested and have been around for a while are generally the types of things you want to be using for security, because they've had a lot of eyes on them and so far they've not been broken. So this has been in since 2013 on PHP version 5.5. So really there's no reason for you not to be using it for password hashing. I'm just going to comment out this for loop for now. And then let's take a look at this password hash function. So again, we're just going to echo out the result of it, and it's password underscore hash. Now for the first parameter, you need to pass in the password. So we do password, and as a second parameter, we need to pass in the hashing algorithm we want to use. So there's a couple of options we can put in here. The first one is password default, and this is the default password algorithm that the PHP core team has currently picked, and which this case it's bcrypt. But please bear in mind, over time this could change. So if there's ever an issue with bcrypt, the PHP team can change the default to something else to make sure the function is always secure. So we can do that by passing in the second parameter, password default. So there is some other options. I'll just paste them in here so you can see them. So there's password bcrypt, which is the same as password default at the moment. But like I said, this could change over time. So if you always wanted to use bcrypt, you'd use password bcrypt here instead of default. There's also password argon2i and password argon2id. So you can use these as well. If you're unsure, then simply stick with password default. The guys who are making these decisions are a lot smarter than me and you, and they know what they're doing. So let's just echo out the output from this password hash function. And you can see this generates a much longer string. But there's a couple of bits of information in this string. If we take a look at the first 4 characters here, so it's $2y $. So when we come to check this password hash against a user's given password, password verify function knows that this password hash is bcrypt. That's what the first 4 characters are telling it. The next 3 characters, 10, 0, $, refer to the cost factor. This means the number of key expansion rounds the bcrypt algorithm has used to generate the password. So we can change this to a lower or higher number depending on your hardware. The higher the number, the longer the hash would take to generate and also longer it takes to verify. But it generates you a more secure hash. By default, PHP sets it to 10, which is a good number for most people, but have a play with this and experiment and find a nice level for your hardware. I wouldn't recommend going any lower than this, but certainly higher won't do any harm. So the next 22 characters in the string are the salt. So password hash automatically salts the password for you. Like in our previous example, we need to store these salts alongside the password, so when we come to verify, we know what hash to use. So this is all done behind the scenes for us with the password verify function, so we don't need to worry about it. In the earlier versions of password hash before PHP 7, you could pass your own generated salt in, but this was removed because people generating their own password salts could produce insecure random numbers. So at the moment it uses dev urand on Unix-based systems, which again is something that stood the test of time, so we know it's pretty good at generating pseudo-random numbers. And then the final set of characters is the actual password hash itself. So overall this produces a 60 character long string. So it produces a 60 character string at the moment, but over time this could increase depending on the algorithm and the cost factor. So the PHP manual recommends that you don't set your storage column to 60 characters and you actually set it to 255. So this gives you flexibility moving forwards if they ever need to change anything. So now that we have a secure password generated and we would normally store this in a database, we need to verify this password. So if I just, instead of echoing this out, I'll put this in a variable called hash. So now what we need to do in a normal application, the password would be coming in from a user input in a form. We'd be getting a hash out of the database for that user. So now we have the given password and their password from the database. We need to compare these. And we do this with the password verify function. So this just returns true or false whether the passwords match. So if we just do an if and we call password underscore verify, and then this needs the password given in by the user, so that's password, and the password that we want to compare it to from the database. So we say hash. And then if these match, let's just echo out passwords match. And we know these match because we're passing the password in and then hashing it straight away and then just echoing it out. So let's just run this. So we see the passwords match. So we hashed the password and then we verified that the hash matches the given password. So further down, let's change password again and we'll just set it to digital. So now the hash is only going to equal penguin, but we've changed the password to digital here. So when we come to verify it, if we just do an else block here and we just echo out passwords do not match, and we'll just give this a refresh, we can see passwords do not match because this password here, digital, does not match what was hashed here, penguin. Now much like in our for loop here, if we just take a look at this and comment it, and we'll just get rid of the salt, and if we just echo out password hash here and just get rid of the salt here, now we're just going to loop over this 5 times and let's just die after it. And we're going to echo out the result of password hash and let's pass in password bcrypt. Let's give this page a refresh. So you can see each time the salt and the generated password is different, but the cost and the algorithm remain the same. So that way, using this information here at the start, password verify will know what algorithm was used, what cost was used, and the salt, and be able to determine whether the passwords match. So I mentioned earlier that you can change the cost, and this is done through an options array as the third parameter password hash. So let's create an array. So I'm just going to call mine options, and this is going to equal an array. And in this array, we can pass a cost. So the default was 10. Let's set a cost of 15 instead. Now as a third parameter to password hash, we can just simply pass in our options. And now let's just echo out hash. Let's refresh our page. And when you refresh it, you'll notice the page takes a lot longer to load this time. And that is because the cost factor is now 15. So it takes much longer for the computer to hash the password.